Hello everyone. Let us solve a question from JEST 2015. It is a question from the solid state physics. The question is, given the tight binding dispersion relation, E, which is equal to E0 plus a sine square ka by 2, where E0 and capital A are constant, and small a is the lattice parameter, The question is, what is the group velocity of an electron at the second Brillouin zone boundary? What is the group velocity of an electron at the second Brillouin zone boundary? First, let us write the expression for group velocity. We know that the group velocity Vg, which is equal to d omega by dk. Vg, which is equal to d omega by dk. And we can write it as 1 by h bar dE by dk. That is, the general expression is Vg, which is equal to 1 by h bar dE by dk. Now E is given. Now we can find out dE by dk by differentiating E with respect to k. E is equal to E0 plus a sine square ka by 2, which is given. Now find out dE by dk. dE by dk, which is equal to 2a sine ka by 2, then cos ka by 2 into a by 2. Now we can write it as this 2 and 2 cancel, that is a sine ka by 2 cos ka by 2. Now we can write it as a by 2 into 2 sine ka by 2 cos ka by 2. 2 sine ka by 2 cos ka by 2, which is nothing but sine ka. That is, the final answer is a by 2 into sine ka. Now we have to find out the group velocity at the second Brillouin zone boundary. So what is group velocity Vg? We can write it as 1 by h bar dE by dk. This is equal to 1 by h bar a by 2 sine ka. We have to find out the group velocity at the second Brillouin zone boundary. So what is the value of k at the second Brillouin zone boundary? The value of k at the second Brillouin zone boundary is plus or minus 2 pi by a. At the second Brillouin zone boundary, the value of k is plus or minus 2 pi by a. Now we have to substitute this plus or minus 2 pi by a in the expression for group velocity to get the value of group velocity at the second Brillouin zone boundary. That is 1 by h bar a by 2 sine ka at k is equal to, first you substitute plus 2 pi by a. Now when you substitute k is equal to plus 2 pi by a in the expression for Vg, the term will be 1 by h bar aa by 2 sine 2 pi, which is 0. Similarly, the group velocity at minus 2 pi by a is also 0.